Hello everyone, good to see you again. In this video, I introduced the case for our last level assignment. Okay, are you guys ready? And then let's get started. The case in the article is about the story in the early 2000s. Now, online and mobile banking is very usual. You can see your balance and transfer money and pay your bills on your smartphones and laptops. But the widespread of online banking just started around 2000. Most financial companies took steps to implement online banking services in the middle of the 1990s, but at that time, many customers were hesitant to conduct monetary transactions over the internet. By 2000, about 80% of United States banks offered online banking, but actual customer use grew very slowly. For example, at Bank of America, it took 10 years to acquire 2 million online banking users. And in 2001, Bank of America became the first bank to acquire 3 million online banking users. At that time, Citigroup had 2.2 million online users, and JP Morgan Chase had only 0.75 million online users. So keep this in your mind and suppose that you are Alan in this article. If you've not yet read the article, please stop watching the video and read the article first, and then come back and watch the rest of the video. The first question in this case is, what is the problem that the top managers faced in Pilgrim Bank? What do you think? It is the following decision-making problem. The top managers wanted to answer, should we charge fees or offer incentives from online banking? Simply think about the options the managers considered. First, what would happen if the bank charged fees on a service? Charging fees would discourage using the service, right? And then what would happen if the bank offered incentives for service? Incentives would encourage using the service. So the manager's question is that, should we discourage or encourage customers to use online banking service? To address this question, top managers asked Alan to analyze the customer data. And then, what is the purpose of the analysis? What do you think? It is to answer the following question. Are online customers more profitable? If yes, the managers would encourage the customers to use online banking. If no, the managers would discourage customers to use online banking. That's the purpose of this analysis. So, in this lab assignment, you are going to help Alan address the top manager's questions by using what you've learned in this course. Alan accessed the bank's database and gathered the following information for each customer in 1999 and 2000. Okay, first, ID. It is an identifier for each customer. And second, profit variable. There are two profit variables. And this variable is the amount of profit from each customer. The number before the variable name indicates the year. So for example, 9 profit indicates the profit variable in 1999, and 0 profit indicates the profit variable in 2000. And third, online. This variable indicates the usage of online banking. If this variable is equal to 1, it means that the customer used online banking service. This variable is also year specific. That is, 909 indicates the usage in 1999, and 009 indicates the usage in 2000. Fourth, demographics. There are four demographic variables: age, income, tenure, and district. And age is a categorical variable, and that is the age variable indicates the age bracket where the customer belonged. And here's the detailed information of the age bracket here. And there are 7 age groups. Age group 1 indicates that the customer was less than 15 years old. And age group 2 means the customer was less than 15 years old. And age group 3 indicates that the customer was less than 15 years old. And age group 4 indicates that the customer was less than 15 years old. And age group 5 indicates that the customer was less than 15 years old. And age group 6 indicates that the customer was less than 15 years old. And age group 7 indicates that the customer was less than 15 years old. And age group 8 indicates that the customer was less than 15 years old. And age group 9 indicates that the customer was less than 15 years old. And age group 10 indicates that the customer was less than 15 years old. And age group 11 indicates that the customer was less than 15 years old. And age group 12 indicates that the customer was less than 15 years old. And age group 13 indicates that the customer was less than 15 years old. And age group 14 indicates that that the customer's age was in between 15 and 24. And age group 3 means that the customer's age was in between 25 and 34, and so on. Income is another categorical variable. There are 9 different income groups. And income group 1 indicates that the customer's annual income was less than 15K. And group 2 means that the customer's annual income was in between 15K and 20K. And group 3 means that the customer's annual income was in between 20K and 30K, and so on. Tenure variable. This variable indicates the length of time the customer conducts business with the bank. So for example, let's look at the first customer tenure variable. Her tenure variable here is 6.33. This means as of 1999, the first customer has used the bank for 6.33 years. And the district variable indicates the geographic region where the customer lived, like the zip code. There are 3 different areas, 1100, 1200, and 1300. And this variable is the other categorical variable. That is, the area code does not have any specific meaning. For example, we don't know if people in 13 area are richer than those in 1100 area. And the last variable Alan had in the data is this bill pay variable. This variable indicates the usage of bill pay feature. And for example, if 9 bill pay is equal to 1, then the customer used the bill pay service in 1999. And here's one more thing. And please note that the bill pay feature was available only for online banking users. So simply think about this. What is the bill pay service? And yeah, this service is an extra service offered to the online banking users, and it allows online banking customers to pay their bill online. So yeah, by the definition, all customers using bill pay service must be online users. That is, 9 bill pay can be 1 only if 909 is equal to 1. So it is impossible that 9 bill pay is 1 and 909 is 0. All right, so far I've explained the details of the variables Alan had. In the raw data, there are more than 31,000 customers. But like customer number 1, there are some customers whose information is missing. To avoid potential problems due to the missing data, I already removed such customers from the data. After this data cleaning, we finally have about 21,000 customers in the data. And in addition, for your convenience, I generated several variables you will need for analysis. And here's the list of the new variables I generated. First, profitability variable. The profitability variable indicates whether the profit from each customer is positive or not. For example, if profit of a customer in 1999, that is 9 profit variable, if this variable is positive, and the customer's 9 profitability becomes 1. If profit of the customer in 2000, geo profit, is positive, then the customer's geo profitability is equal to 1. And second, the group indicators for the categorical variables. We have 3 categorical variables: age, income, and district. In analysis, especially for predictions, we need group indicators for those variables. For example, we need an indicator for age group 1, which becomes 1 if the customer belongs to age group 1. And there are 7 age groups, but the last group will be designated as the baseline, and we need only 6 indicators for the other groups. This avoids a statistical problem, which is well known as the multicollinearity. In the same manner, I generated 8 indicators for income groups 1 through group A, and 2 indicators for district 1100 and district 1200. The last income group 9, and the last district 1300, will be designated as the baseline as well. And please note that those categorical variables are assumed to not change between 1999 and 2000. So as for age and income, we don't know the exact ages and income levels of the customers in 2000 in the raw data. So we cannot track the exact age groups and income groups of the customers in 2000. So we approximate the age groups and the income groups in 2000 by using the same groups as used in 1999. And as for the district variable, we simply assume that the customers did not move during their years. And last, tenure variable in 2000. Yeah, this variable, 0 tenure. We don't have this variable in the raw data, but I generated it. And this is very simple. As a year passes, the tenure variable increases by 1, by the definition, right? Thus, the tenure variable in 2000 can be easily computed by just adding 1 to the variable in 1999 like this. And I already did for your convenience. And then, what to do in this assignment to help Alan? You are going to write a full analysis report. You may find that the answer sheet of this assignment is a little bit different from the old ones. And the answer sheet looks like a template of analysis report. And you are going to fill out that template. That's your job, okay? And in details, you first need to analyze the data in Excel and SPSS. From your analysis results, you will fill out the tables and figure in the answer sheet. And then you will complete the introduction and main body and conclusion in the answer sheet. In the introduction and conclusion, there are several questions in gray bullet points, which are guidelines of the introduction and conclusion. And you will write your own introduction and conclusion, and your introduction and conclusion must clearly address the questions. In the main body, you will find some blanks in gray, and your job is to fill out the blanks. And of course, you will find my guideline about what you should put in each blank. And so far, I've briefly introduced the lab assignment. Now I'm going to illustrate what we will do in analysis. We will do 2 different analyses with the data to investigate whether the online banking customers are more profitable or not. And first analysis is a descriptive analysis, average, and count. The research question here is that, is there any difference in profits between online banking users and non-users? The easiest way to see this is to compare the average profit between online banking users and non-users, like this table, okay? And we can do this by using Excel pivot table. For each year, you can compute the average of profit for the 2 groups, online banking users and non-users. For example, for 1999 data, you can generate a pivot table that evaluates the average of 9 profit variable for the 2 groups. These 2 groups divided by 909 variable. And also, you can generate another pivot table that evaluates the average of 0 profit variable for the groups divided by 0 profit, 0.9 variable, just for 2000 data. Very simple, right? But simple average can distort the result if there are very, very and extremely profitable or extremely not profitable customers. For example, let's think about this. If all customers made positive profit, but one customer made a billion dollar loss, then the average is highly likely to be negative, right? This just distorts the result, right? So, as a complement, we can see the difference in the number of profitable users between the online banking users and the non-user group. As explained, we already have the variable, right? The profitability variable. This variable indicates whether the profit was positive or negative. If it is 1, the profit was positive. So the sum of this profitability variable becomes the count of positively profitable customers, right? And we can also do this by using Excel pivot table. For each customer, you can compute the sum of profitability for the 2 different groups, online banking user group and non-user group, right? For example, for 1999 data, you can generate a pivot table that evaluates the sum of non-profitability for the groups divided by 909 variable. And for 2000 data, you can generate another pivot table to compute the sum of zero profitability for the groups divided by 009 variable. And please note that the total number of online banking users and non-users could be different from each other, okay? And this leads to some difficulty, to directly interpret the difference in the number of users between these two groups, okay? So maybe it would be better to look at the proportion of those positively profitable customers in each group to understand the difference between these two groups, okay? So you are going to compute the proportion as well. How? You just simply divide the sum of the profitability variable by the total number of users for each case. The second analysis is logistic regression. The goal of this analysis, the series of analysis, is to identify who are profitable, right? And the logistic regression will be the best to figure out the profile of profitable customers. Again, logistic regression requires a binary dependent variable. In this case, we want to know if a customer is profitable or not. And in the data, we already have the binary indicator, the profitability variable, right? So the profitability variable is the best choice as the dependent variable of our logistic regression. And the other variables will be used as the predictor variables or independent variables, these IVs. But please note that you must exclude the profit variable. Why? The reason is that profitability, which is our dependent variable, that is already generated from the profit variable. So including this profit variable into the set of predictors to explain the profitability variable is like to say that, oh, this customer is profitable because she's profitable. Yeah? We don't want this to be the analysis. We want to know which factors drive customer profitability. Okay? So we must exclude the profit variable in the from the set of the predictors. In addition, please don't forget we have 3 categorical variables: age, income, and district. In SPSS, they should be designated as categorical variables. And our analysis strategy is as follows here. We first estimate a logistic regression with 1999 data. This is estimation step or calibration step. And we then validate the result with 2000 data. That is the validation step. And here is the detail of each step. You will use 1999 data to estimate the logistic regression. That is, 9 profitability becomes the dependent variable of the logistic regression, and the other variables in 999, 9 online, 9 age, 9 income, 9 tenure, 9 district, and 9 bill pay, those variables become the predictors. And SPSS will give you the estimation result, and you will summarize the result by filling out this table and interpret the numbers in these tables to understand the profile of the profitable customers. Once you get the estimate, you can generate predictions, right? And using 2000 data, you can generate the prediction of the profitability in 2000. And think about this. You already have the profit information in 2000 for each customer. And it means that you have the profitability variable, the actual profitability variable in 2000 for each customer. Then you can validate the performance of the logistic regression model here. How? You can compare your prediction to the actual profitability variable in 2000, right? If the logistic regression works well, then your prediction must be very close to the actual profitability. So for this validation, you will draw a misclassification table, and you will compute the misclassification rate, and you will draw the lift curve. So this is the misclassification table, and you can compute the misclassification rate from this table, and you are going to draw the lift curves. So I highly recommend you to review what they are, what the misclassification table is, and what the misclassification rate is, and what the lift curve is in the logistic regression lecture video, and before coming to our lab meetings. I really recommend you to do this. All right, that's all I have in this video. Then see you in the lab. Bye-bye.